Then we talk about how to fill the data. Now, the fill kind of signifies that there are holes to be filled up. And these holes, uh, because if they are valid data like 8 or 3 or 9, we could always use replace. So that's like fill, except you fill in places where there are nines and you fill it with a particular value like 2. So replace can be thought of as fill. The fill, F-I-L-L here in pandas specifically refers to uh, the sort of holes, the nans that we talked about or have seen earlier on. Yeah, okay. So that when we have the nans, it of course increases the difficulty of readability. But more importantly, if you take the average, whenever there's a nan, it's sort of like a landmine. It actually, makes the all the calculations becoming nan, right? So that's a problem, and we cannot proceed at all with any single occurrence of nan. So it's very frequent that we will use a standard replacement of nan values with something else, and that something else, that some other number, depends on the situation. It might be easy to think about it as always fill with 0, but sometimes we fill with the average of all the non-nan values just so that the statistics are not affected. The average of averages is the same average, so we're not changing the average. There are times where we might fill in with the median, so we don't change the median too much, etc., etc. But by and large, it's very contextual, depends on circumstances. Let's say now we want to fill with 0. All the nans will be filled with 0. Now notice it's filled na, na. Na is a bit like not applicable, not a number, that's nan. And there's also a null, null, for empty strings. All these na, nan, and null, they are considered na. They're considered not applicable, right? So fill na, fill na will actually fill up all the nans and all the nas and all the nulls, null, not the string null, but the system null, right? It's a bit like the none, none, in our Python programming world. So when we tell pandas df2, look at df2, which is this guy here, having a lot of nans, please fill up all the nans with zeros, and then out comes this. Now let me ask you, this statement here, is it returning a new copy, or is it going to modify df2? Do you remember what's the principle? So you don't have to memorize all the functions, hundreds of them even, in pandas. You don't have to memorize. It's just impossible. For me, I still uh, on and off again, every day, every hour even, to have to web search the documentation for pandas because I cannot remember which attribute works in this function, what value should I supply in order to activate certain behavior. So still look up the documentation. There's no shame in that. All right, definitely use that. It's I would say shameful, but it's dangerous to just base on I think we should spell as in place, in capital P place, or in lower P place. I don't know. No, it's dangerous. At best, you did get a right answer, but it was after 5 attempts, right? Because you spell wrong. At worst, you supplied the wrong undocumented data and it activates strange behavior that erases your data. No, so don't try, right? So better be clear, check out the documentation before you fill up the commands. So fill NA, all right, with 0. So in this case, to answer the question, it is going to return a copy because principle is I did not explicitly say change in place, right? So in place is false. What if I want to save memory? I want to modify df2 directly. I would then dot fill NA 0 and supply the positive authorization. Yes, in place is true. Okay, so it's quite easy to remember all. Now, let's switch over. to our spider screen. So that was from earlier exercise where we have already extracted the all the necessary details, right? So now what we want to do is to basically practice. Okay, we talked about replacing. Uh, First of all, let's create a DF3. So creating a DF3 now, it should be no surprise to us to see that we are basically listing a list of lists, and the list value, the inner list values, they are basically row based. So we won't get, vertically A399, but horizontally A399. That's important. Huh? What happens if you actually want a vertical A399? So you want two columns of four, two columns and four rows instead of two rows and four columns. We'll see in a while. Huh? So let's create DF3. So here we have two rows and four columns as shown, as manifested by the way we lay out the numbers. However, supposing you want two columns and four rows, but when you type it out, the values in your program, it's so inconvenient to write, 8931, very hard because the data that naturally comes to us is two columns. One column is 8399, second column is 9107. But that's column. So how do we do it? This is where you take advantage of the way Pandas assimilates this data that we give. Pandas always takes the inner list as row. So we create this row first, and we can always then say the transpose of this data frame. So df3.transpose, yeah, is going to be basically reflecting off the diagonal. So row becomes column, column becomes row, and we get this. Okay. Now, of course, you might need to relabel the columns and call it A, B, and 0, 1, 2, 3, but that's quite easily done, right? So we can always say df3t dot columns equals to A, or we can list of AB, df3t dot index equals to range of 4. So what is df3t now? Well, we now get, right? So it's quite easy to get even raw data that are columns kind of orientation, and we can do it. All right, so now let's come back to our lab here, and we get back this again, just rerun to refresh the data. Now, what do we want to do? We want to say something like df3, df4, store it in df4, replace 9 with 2. And so this is df4. All the 9s become 2. Okay. Now we can also purposely define fill our NA. So what's our NA? Remember here in our DFB, let's look at DFB. What's our DFB? Our DFB was actually not fully computed because it was A, B, C, D, E, right? So let's get back the same DFB that we got before, because I modified the columns just now. Right, so now we have this as seen in our slide, yeah? And we have a lot of nans to deal with. And we can definitely perform a calculation to fill NA. So DFB dot fill NA with a 0 and pass it to DF5 and see what is DF5. So let's run that. So now this is DF3, this is DF4 with the 9s changed to 2. This is DFB, just to see it again. And this is, where's my DF5? No, this is DF5, sorry, because we didn't print out DFB. So this is DF5, and notice that the nans, they are gone. This is DFB. The nans are gone, and in their place, it's filled with 0. What about 999? And of course, not surprisingly, we can do that. Yeah, okay. So let's change it back to 0. Okay, any questions? I'm sure you have. Put it in the comment. I'll do my best to answer them as soon as possible. All right. Good. And then, if you're ready, let's quickly take a short break and we'll continue to our next two commands.